Have you ever wondered what goes inside your food? Millions of tons of food products are consumed every day. What makes your meal or drink sweet? Is it always from a natural source? There is only one man who can answer those questions. When the sun goes down and the stars are shining, one superhero cannot sleep. His name is Sweet Man. His body is completely made up of pure sugars and artificial sweeteners. He only has one question on his mind.
How sweet are things?
That's why Sweetman spends his nights at the library doing research. Sweetman's favorite compound is aspartame, since it is roughly 200 times sweeter than table sugar, also known as sucrose. Aspartame is composed of two common amino acids linked together, phenylalanine and aspartic acid. Sweet man, could you tell me about the history of aspartame?
Sure, narrator, but first I must go back in time. A chemist at GD Searle named Jim Sclatter was working on new approaches to gastric ulcer treatments. In 1965, while synthesizing a peptide intermediate called aspartyl-phenylalanine, he accidentally and mindlessly spilled some on his hand, and forgot to wash it right after, which, for a chemist working with possibly toxic chemicals, is bad practice. As he was reaching for a piece of paper, he licked his finger, and noticed that it had a sweet taste to it. Again, this is an unsanitary lab technique for a chemist. He then invited a friend to try this sweetener in their coffee, and thus the unintended discovery of what is now known as aspartame. Gonna get paid.
So Sweet man, what is the process of making aspartame?
The synthesis of aspartame begins from obtaining two amino acids, phenylalanine and aspartic acid. Both amino acids are obtained from fermentation. Phenylalanine is reacted with methanol to produce phenylalanine methyl ether. Aspartic acid is protected with a carboxybenzyl group and dehydrated to aspartic anhydride. Aspartic anhydride and phenylalanine methyl ether are mixed in a reactor. The reaction can occur from room temperature to 60 degrees Celsius over the period from 4 to 12 hours depending on the temperature used. If the reaction is performed at temperature over 80 degrees, it results in a high ration of byproducts. The reaction produces two isomers, alpha and beta. These two have to be separated, as only the alpha isomer has the sweetening properties. A 4:1 or 10:1 mixture of either dichloromethane or ethyl acetate to acetic acid is used to dissolve the mixture. Separation process involves 85% phosphoric acid, which is about 1.2 to 5 moles per 1 mole of aspartame, that forms the phosphate complex with the alpha isomer only, which precipitates out. The precipitated aspartame phosphate is filtered out, dissolved in water, and neutralized using sodium carbonate or sodium hydroxide to produce aspartame, with 73 to 90% yield.
Sweet man, my industrial chemistry professor really likes statistics. Could you tell me some on aspartame?
Sure. British-based company Tate & Lyle found that in 2003, artificial sweeteners contribute about 10% in the sugar and sugar equivalent market, which is about 150 million tons a year in production. 55% of consumers are from the Americas, 22% from Europe, and 22% from Asia. The remaining 1% of consumers are from the rest of the world not mentioned previously. Aspartame is the most popular among the other sugar substitutes, constituting to about 55% of artificial sweetener sales. 13% of the sales comes from sucralose. So if you think about it, artificial sweetener is a growing industry in the sugar market, as reflected from the numbers previously stated. Aspartame is found in over 6,000 products, varying from different food and beverages. It is clearly dominant over the other artificial sweeteners. Some of the products wherein aspartame is found are diet beverages, breakfast cereals, gum and candy, ice cream and ice cream toppings, jams and jellies, juice drinks and juice blends, flavored water products, meal replacements, nutritional bars, and many others. Alright, enough of this.
Breaking news on aspartame. We go live to our secret informant.
I am here to talk about the negative effects of aspartame. Canada Health lists the following allegations. The methanol in aspartame is toxic and is linked to numerous health problems including lupus, blindness, and also mimics multiple sclerosis. Aspartame is especially dangerous for people with diabetes, causes cancer and brain tumors, can trigger allergic reactions, and causes seizures.
That is all fake news, bruh.
And that from our sponsor. Back to our secret informant.
All of these allegations are not supported and have the following arguments refuting them. Methanol is not foreign to the human diet. Pectin in fruits and vegetables produces methanol when metabolized. A cup of tomato juice contains 6 times more methanol than a cup of soft drink that contains aspartame. When studied by Health Canada, it was determined that aspartame can be used safely by people with diabetes. Scientists have not found a link between aspartame consumption and cancer. Clinical studies have shown no link between aspartame consumption and seizures or allergic reactions. Haters gonna hate.